Welcome to Programming Fluency. This is section 9.1, Reading and Writing Text Files. Every program you have written so far forgets everything the moment it exits. In this video, you will learn how to save data to a file and read it back later. Let's begin. Every program you have written so far loses its data the moment it exits. The user types in 50 scores, you compute an average, and then the program ends and everything is gone. Files fix that. Let's see how real software remembers things. This is the plan for this video. First, the file pointer. You open a file, use it through a pointer, then close it. That open, use, close rhythm runs through everything here. Next, the mode strings. Read, write, and append, and you will see why the write mode can erase your whole file. Then writing text. fprintf for formatted output and fputs for raw lines. After that, reading text. fscanf for separate fields and fgets for whole lines. Finally, robust parsing. You combine fgets and fscanf so your program survives bad input. Let's start with the problem. Every program so far runs, computes an answer, and then exits and wipes everything clean. The user's data vanishes the moment the process ends. A file solves this. A file is data that lives on disk, independent of any running program. You can write it tonight and read it back next month. Nearly every useful program reads or writes files. Editors, databases, compilers, games. To remember anything at all, a program needs persistent storage. That is what a file gives you. Let's picture it. In C, you do not touch the file directly. You work through something called a stream. Think of the file as a scroll, read or written through a moving cursor. The function fopen unrolls the scroll and places the cursor at the very start. Each read or write function moves the cursor along as it goes. And fclose rolls the scroll back up and saves any data still waiting in a buffer. Open, use, close. That is the whole life of a file. Let's look at the core pattern. The function fopen opens a file and hands you back a file star. That is a pointer you pass to every read and write function. We call fopen with the name output.txt and the mode W for write. If fopen fails, it returns null, so we check for null right away and bail out. This is the same discipline you used with malloc. Then fprintf writes 2 lines to the file. fprintf is exactly like printf, except the first argument is the file pointer. Finally, fclose closes the file. After running, output.txt contains the 2 lines, hello file, and the answer is 42. This figure shows the 3 phases of a file's life. First, open. Fopen returns a file pointer or null if it fails. You always check for null. Second, use. You read or write through that pointer as many times as you like. Third, close. Fclose flushes any buffered data to disk and releases the file. After fclose, the file pointer is invalid. Using it is undefined behavior, exactly like using a pointer after free. Same acquire use, release pattern as malloc and free, just a different resource. The second argument to fopen is the mode string. It controls what you can do with the file. There are 3 you will use constantly. Mode R opens an existing file for reading and returns null if the file does not exist. Mode W opens a file for writing. If the file exists, it truncates it, meaning it erases everything. If the file does not exist, it creates it. Mode opens for appending. It writes at the end, keeping what is already there and creates the file if needed. Now the trap to remember. Mode W erases the file's contents the moment you open it, before you write a single byte. Open your important data file with W by mistake, and the data is gone. Let's slow down here, because this is the most painful file bug there is. Suppose you have a log file that has been collecting entries for weeks. You open it with W when you meant A. The instant F open runs, every existing line is destroyed. Not when you write, but the moment you open. The correct code opens app.log with mode A for append. Each write goes to the end, and the old entries stay put. For any file that grows across many runs, like a log, append is the only safe choice. Now let's write formatted text. fprintf works exactly like printf, but it sends its output to a file instead of the screen. We have a name, a score, and a GPA, and 3 fprintf calls write 3 labeled lines. The result is exactly what you would expect. Name Alice, score 95, GPA 3.87. The good news is this. Every format specifier you already know works the same way. %D, %S, %F, %.2f only the destination changes, screen versus file. When you are writing a plain string with no variables to insert, fputs is simpler. Fputs writes line 1, then line 2, each with its own new line. One thing to watch. Fputs takes the string first and the file pointer second. That is the opposite order from fprintf also. Fputs adds no new line of its own, so you include the backslash in yourself. You may not have realized this. You have been using file streams since your very first program. C automatically opens 3 streams when your program starts. Standard in for reading input, which comes from the keyboard by default. Standard out for normal output, which goes to the terminal. Standard error for error messages, which also goes to the terminal. In fact, printf is just fprintf directed at standard out, and this is why we write errors to standard error. Run./program greater than output.txt, and the greater than sends standard out to a file. The error messages still show on the terminal, so the user sees them. Now let's read. fscanf reads formatted fields from a file, just like scanf reads from the keyboard. Here we read an integer, a string, and a double using %d, %49s, and %lf. The output lines up each record. 101 Alice, 102 Bob, 103 Charlie. fscanf returns the number of items it successfully read. We compare that to 3, so the loop keeps going while all 3 fields parse. %49s caps the string at 49 characters, so a long word cannot overflow the buffer. fscanf reads word by word, but sometimes you need a whole line, and a line can contain spaces, which %s stops at. That is where fgets comes in. Fgets reads one complete line into a buffer and takes 3 arguments. The buffer where the line is stored. The size. Fgets reads at most size -1 characters, then adds a null terminator. And the stream, the file pointer. Fgets returns null at the end of the file, or on a read error, so the while loop reads until there are no more lines, and we check f error afterward to tell a real error apart from a normal end of file. Notice the printf uses %s with no backslash in, because fgets keeps the new line, so it is already inside the line. This detail trips everyone up. fgets keeps the trailing new line in the buffer. If the file line is hello, then after fgets the buffer holds hello \n, not just hello. This matters when you compare strings. Comparing hello \n with hello will never match. The standard fix is simple. Take the length of the line. If it is greater than 0 and the last character is a new line, replace that new line with a null terminator. You will use this read, then strip pattern constantly. Professional C code prefers this pattern. Combine fgets with fscanf first. Fgets reads a whole line into a buffer. Then fscanf parses that string rather than the stream directly. We read each line, then try to parse an integer and a double out of it. If fscanf returns 2, both fields parsed and we print them. If not, the line was malformed, so we report it and move on. The next fget starts fresh on the next line. This is much safer than fscanf alone, because a bad value with fscanf can leave stray characters stuck in the stream, making every later read fail in confusing ways. Let's look at the first common mistake, since it is worth repeating. You open data.txt with mode W, meaning to add a new entry, but W truncates. The moment fopen runs, all existing content is erased. If data.txt held 1,000 lines, they are gone, and only new entry remains. The fix is to use mode A for append, which keeps the existing content and adds your line to the end. The second common mistake is forgetting to check fopen's return value. This code opens config.txt and immediately calls fgets, but if the file is missing or unreadable, fopen returns null. Passing null to fgets is undefined behavior, and it usually crashes. Files fail to open for many reasons. A wrong name, a missing directory, no permission. So always check fopen before using the pointer. If it is null, print an error and return. Let's recap. File input and output follows the same rhythm as dynamic memory. Acquire, use, release. Fopen returns a file pointer and fclose flushes and invalidates it. Always check for null. The mode string controls access. R reads, W writes and erases or appends. You write with fprintf for formatted output or fputs for a raw string. You read with fscanf for fields or fgets for whole lines. Remember that fgets keeps the trailing new line, so strip it before you compare strings, and prefer fgets plus fscanf for parsing that survives bad input. Next, text files store human-readable characters, but images, executables, and structs are binary data, raw bytes. In the next video, you will learn fread and fwrite for binary input and output, including saving a struct directly to disk.